My name is Keisha Wallace, and I'm with ACEWAL Scholars. Today we will be learning solving 1- and 2-step equations. Let's begin. So, what are our lesson goals? Our first goal is to solve 1- and 2-step equations using the additive property of equality. And our second lesson goal would be to solve 1- and 2-step equations using the multiplicative property of equality. So, let's begin. First, what is an equation? Well, an equation is a mathematical statement that sets two expressions equal to each other. Let's look at an example. Let's say we have 3 plus 4, which is an expression, equal to 8 minus 1. Well, 3 plus 4 is an expression, and that is equal to a 7, and 8 minus 1 is an expression, and that is also equal to 7. Putting these two expressions together with an equal sign gives us an equation. Now, what happens if we replace parts of the expression with a variable? And a variable is just some symbol or letter that we can use in place of a number. Well, when this happens, we have to solve the equation to find out what that variable is actually equal to. Now we'll be using the different properties that we talked about earlier to actually solve equations. So, let's look at the additive property of equality to solve one-step equations. Well, the rules for additive property of equality are as follows. If the same amount is added or subtracted to both sides of the equation, then the equation is still true. So, to keep the equation true or balanced, the same thing must be done to both sides. So, what does this mean? Well, when we are trying to solve an equation, we want to isolate the variable. That means get the variable by itself. In order to do that, what's on one side of the equation with the variable needs to be moved to the other side. And so, we use the additive property of equality to do that. So, let's look at an example. Example 1. Let's say we have x plus 5 equals 23. Well, we need to find out what that variable is actually equal to. So, in order to do that, we're going to use the additive property of equality. We want to isolate the variable, get the x by itself. So, what's on the same side of the equation with the x? Well, the 5 is. So we need to move the 5 to the other side of the equal sign. In order to do that, we do the opposite. So we're going to minus 5 on both sides. When we minus 5 on both sides, the first set of 5s that are on the left side will go to 0. So we will end up having just x equals, and then 23 minus 5 is 18. So that's our answer, x equals 18. Let's go to example 2. So let's say we have x minus 6 equals 18. So we got to do the same thing. We need to get the variable by itself. We need to isolate that. So in order to do that, we're going to take the minus 6 to the other side of the equal sign. And we do that by doing the opposite. So what's the opposite of minus 6? Right, it's plus 6. So we're going to add 6 on both sides of the equation. The 6 cancels out, and we're left with x equals 24. And that's our answer. Okay, let's move on to our next example. Let's say we have 10 plus s equals 18. Again, we need to solve for our variable, which is s. So we need to move 10 to the other side of the equal sign, or to the other side of the equation. So 10 is a positive number. So we're going to subtract 10 on both sides of the equation. The 10s on the left side cancel out, so we're left with s equals, and what's 18 minus 10? Well, 8. So s is equal to 8. Let's look at example 4. So in example 4, we have negative 10 equals x plus 5. Now we'll notice this equation looks slightly different. Why? Because we have our variable on the other side of the equal sign. Well, it's okay. We still go about it the same way. Now, what is the procedure? What do we want to do? We want to isolate that x, get it by itself. So whatever is on the same side of the equation with the x, it needs to move to the other side of the equation. So what's on the same side of the equation with the x? We have the plus 5, right? So in order to move to the other side of the equation, we do the opposite. So what's the opposite of plus 5? Minus 5. So we're going to minus 5 on both sides of the equation. So the positive 5 and minus 5 get canceled out. So we have a negative 10 minus 5, which will give us negative 15 equals x. Now, let's look at one-step equations using the multiplicative property of equality. Well, what are the rules for the multiplicative property of equality? Well, let's see. If the same amount is multiplied or divided to both sides of the equation, then the equation is still true. So, to keep the equation true, or we could say balanced, the same thing must be done to both sides. So, let's look at an example. Example 1. So in this particular equation, we have 5x equals 35. And again, we want to get that x or that variable by itself so we can find out what it's equal to. In order to do that, anything that's on the same side of the equation with the x needs to be moved to the other side. So you'll notice 5 and x are right next to each other. In math, that means that you are actually multiplying 5 and x by each other. Now, to get that 5 to the other side of the equation, we have to do the opposite. So what is the opposite of multiplication? Well, division. So we're going to divide both sides by 5. Now, 5 divided by 5 is just going to give us a 1. So we have 1x, and then 35 divided by 5 is equal to 7. Now, in math, if there is a 1 in front of the x, and as we know, our 1 is called our coefficient, we don't need to write it because it's just saying we have 1x there. So we could just write this as x equals to 7. All right, let's look at example 2. In example 2, we have negative 2x equals 24. Okay, well, again, we need to get x by itself, so we're going to need to take that negative 2 to the other side of the equation. Now, what's going on between negative 2 and x? What's this operation that's going on between the two of them? It's multiplication. The negative 2 is literally being multiplied by the x. So, to get the negative 2 to the other side, we do the opposite of multiplication, which is division. So we are going to divide both sides by negative 2. Negative 2 divided by negative 2 is just 1. So we have 1x equals, and then 24 divided by negative 2 is a negative 12. And again, do we need to put that 1 in front of the x? No, we don't. Because it's just saying there's 1x there. So we're just going to write this as x equals negative 12. Let's move on to example 3. Here we have x divided by 4 equals 24. So we're still using the multiplicative property of equality, but we're going to attack this in slightly a different way. Now, let's look at this problem. What is going on between x and 4? Well, x is being divided by 4. If we're trying to find out what x is equal to, we've got to do the opposite to get x by itself on one side of the equation. So what's the opposite of division? Let's think about it. The opposite of division is multiplication. So we're going to multiply both sides by 4. Now, remember, whatever you do to one side, you got to do it to the other. That's why we're multiplying both sides by 4. The 4's are going to cancel out, and we'll be left with x equals 24 times 4 is 96. And that's our answer. Let's look at two-step equations. So now we're going to combine additive and multiplicative property of equality. Example 1. We have negative 2x plus 5 equals 23. Now, we always implement the additive property first. This is a little different than order of operations, so make sure you take note of this. When solving equations, we always implement the additive property before we implement the multiplicative property once each expression that's on both sides of the equal sign have been simplified completely. So if we look at each expression that is located on both sides of the equal sign, so we have one expression that's negative 2x plus 5, and then the other expression is 23. Both sides are completely simplified. So now we can solve the problem. As I said earlier, we're going to implement the additive property of equality first. So we're going to minus 5 on both sides, since the original equation has negative 2x plus 5. All right, so the 5's cancel out because 5 minus 5 is 0, and we're left with negative 2x equals 18 because 23 minus 5 is 18. We're not done yet. Now we're going to implement the multiplicative property of equality. So we have negative 2x equals 18. What's going on between the negative 2 and the x? Well, they're being multiplied by each other. So we do the opposite to get the x by itself, and we divide on both sides. So if we divide by negative 2 on both sides, we get x is equal to negative 9. And that's our answer. Let's move on to example 2. In this example, again, we're going to be using the additive and multiplicative property of equality to solve. So what are we going to do first? Let's see if you can remember. Yes, we're going to use the additive property of equality first. And we're going to do that by moving what to the other side? The plus 7, yes. Now, to move the plus 7 to the other side, what do? We minus 7. Excellent. So the plus 7 and the negative 7 will cancel out, and we'll have 3x equals negative 30. Now, how do we get that negative 30? Well, negative 23 minus 7 gives us negative 30. So now we can implement the multiplicative property of equality. And to do that, we're going to divide by 3 on both sides. The 3's cancel out that are on the left side because 3 divided by 3 is just 1. And we have x equals negative 10 because negative 30 divided by 3 is negative 10. Let's move on to example 3. Let's say we have 3x divided by 4 equals 6. You can also say this as 3/4 x equals 6. So what do I want to do first? The first thing is I want to bring the 4 to the other side of the equation. So I'm going to multiply by 4 on both sides. The 4's on the left side cancel out, and we're left with 3x equals, we multiply 6 by 4, and that gives us 24. Now we have 3x equals 24. So how are we going to solve this? Well, we can divide by 3 on both sides. The 3's cancel out, leaving us with x equals 8. Let's look at another example. Let's say we have negative x divided by 2 equals 6. Well, this is the same as saying negative 1/2 x equals 6. And again, we want to first bring that 2 to the other side of the equation. So since it's a negative 1x divided by 2, we're going to take that 2 and multiply it by both sides. We'll be left with negative 1x equals 12. Now, we want to get x by itself, but it's not by itself yet because it has that negative 1 in front. So we're going to divide by negative 1 on both sides. Our answer is now x equals negative 12. Again, my name is Keisha Wallace with ACE Wall Scholars. Thank you so much for giving me the opportunity to teach you this lesson.